Hi, my name is khiaData. Now I will discuss you a simple introduction and how to make a simple algorithm for transposition or transpose sort. This is my project and data structure. For now, I will show you a simple introduction in a PowerPoint presentation. Transpose sort. Introduction. Transpose position sort, also known as a brick sort, is relatively simple sorting algorithm developed originally for use of all parallel processors with local interconnections. It is a comparison sort related to bubble sort, with which it shares many characteristics. Functions. It functions by comparing all odd and even indices, pairs, and adjacent elements in the list. If a pair is in a wrong order, the first is larger than the second, the element are switched. The next step repeats for even odd index pairs of adjacent elements. This is alternates between odd, even, or even-odd steps until the list is certain. Flow. Recall the operation of a bubble sort algorithm. For elements, a first phase iterates through the element, comparing and exchanging neighbors with operations. After the first phase, the larger element will have bubbled to the end of the array. Since the largest element appears at the end of the array after the first phase, the second phase needs only iterate times. The bubble sort, however, takes sequential steps. See here the algorithm. A bubble sort iterates only 8 times. 3 is compared by 6, and if 6 is less than 3, then it will change position, like 6 and 2. 2 is compared by 6, and if 2 is less than 6, then it will change position. A bubble sort change position or takes sequential steps after comparing. However, a transposition sort makes use of pipelining techniques that ultimates run many phases of bubble sort in parallel. The second phase of bubble sort algorithm can begin after the second iteration of the first phase. Third phase can begin after the fourth iteration, the fourth phase after the sixth iteration, and so on. In the effect, each parallel computational steps can compare either odd or even neighboring pairs. See the algorithm. We can see here that it is compared in a parallel position. 3 is compared by 6. If 6 is less than 3, then it will change position, like 3 and 1. 3 is compared by 1. If 1 is less than 3, then it will change, like this. If 1 is less than 2, then it will change. If 2 is less than 1, then it will change. If 0 is less than 1, it will change like this, and so on. We can see here how it compares by bubble sort. Bubble sort is only iterates afterwards. This iterates and run in many phases, and it is compared in a parallel position. And that's the introduction. Now I will teach to you how to make a simple transpose algorithm. Input and import java.io for a package of input and output. Now make a public public static void main string args. This is for the main class of your now type in a buffered reader for the input of your algorithm. Now make a variables that will hold the values of your numbers. I will make a row and a column for my comparing of the numbers that I will be inputting. Now make an array and this will hold the values and how many values that you want to input. System.out.print is used for displaying any kind of message you want to insert. Integer.parseInt will initialize your variables. Now make a for loop. Loops will compare your numbers that you have been inputted, and this will transpose the numbers into a parallel position. After making a loop, your loop will be much more depends on how many times you want to compare. Now let's run. If you're finished, then save it. Then you will see the output when you run it. I will write a tree, but this will show how to compare. I will input a number, any kind of number to be compared. Let's see how it compared. You can see here 12. It is list in 1 lines. 12, 10, 32, 40, 65, 66, 70, 99, 44. Now let's see how it becomes in a parallel position. 12 is compared and 10, 32, 40, 65, 66, 70, 99, 44. Now they are all in parallel position. That's all. Thank you for listening.